So hello guys, here we are again with my UEFI and NT Windows debugger or system debugger. This is the very first moment when you boot the machine. By the way, this is a VMware Windows 11 64-bit machine. So the first moment when you boot the machine, you are presented the system is frozen, and you are presented this interface. You can see the registers at the top, then the data window, then the code window, and then the console, right, and the status bar, and the command entry and all that. By now, let's continue execution with G. Let's go here and continue execution. Well, you can see, by the way, the code window has the assembly machine code for the instructions, and to the left there will be the code selector and the offset, right? Similar to that in the data window, there is also a selector, and there is also the offset, and then there's different ways of presenting the data. In this case, they are bytes, but we can change that, and you can see later. Let's do G command and press enter. Now Windows will start to load, and the very first instruction of NTOS kernel, as you can see there, NTOS kernel exe bang entry. This is the entry point of the module of NTOS kernel exe. We can trace. So these are the very first instructions of the NTOS kernel. There was previous code executed, the boot mgfw, which .efi, which is the Windows UEFI loader. There would be more modules, winload.efi, I think, which is an intermediate module, and then that would load the NTOS kernel and start executing it. So we are executing these first instructions of the kernel. Again, we can do trace, pass, we can see some stuff going on here. You can see some symbolic information. By now it's only the exports of the module, but that's fine. So let's press G again to let it continue execution. And well, since this is configured for the anti-kernel debugging and all that, the boot up is a bit slower, but it's nothing that the debugger makes happen. I mean, it happens anyway. This is a small stop that happens whenever you have the debugger configured to be attached, the Windows debugger, I mean, the WinDBG. But in a few seconds it should continue the execution and start, show us the desktop, and that's it. Let's see if it continues. Okay, that's a typical thing. So in a few seconds we will be shown the desktop. Windows will have booted. That's it. Okay. Now I will put the password here. But what I can do anytime I want is I can press Ctrl and D in the keyboard, and Windows will freeze this is a 2-processor machine, but whatever the machine is, all the processors will freeze, and we will be shown this window again, the debugger window. By the way, we can if we don't want to see the registers, for example, we can toggle the registers on or off. The same for data window, we can toggle it on or off, or make it different size. For example, let's make it a bit bigger. Sorry, Windows Data 20. It doesn't let me because it is not fitting. We can, by the way, make it bigger, pressing Ctrl and the cursors to the sides or whatever. We can Ctrl Alt and cursors, we can move the window, which is transparent. For example, window data, in this case 20, we have more data there, or let's put it again as smaller and a bit more code, which is Windows Assembly. Let's put some more lines. Again, we can remove assembly if we want. For example, if we want to edit data, we would put window data even 40 here, and we can do, bigger data addition. But let's go back to the more or less standard way. Window assembly 30, let's say. We can tab to toggle between the windows. In this case, we are in the data window. By the way, it doesn't matter if the data window can't see something because the page is not present or because the segment limit has been reached, whatever the reason, it will just show it as question marks here, but otherwise you can access whatever is present in the current machine configuration. You can access. There is also a concept which is the data selector. We can change selectors here. Now it's the selector is selector 20, which is, I think it's, yes, so this is the selector for no, it's 30, sorry, which is, this is the selector for kernel mode data, let's say, or stack or whatever. But we can also change it, for example, to see the code selector. So we could see code selector, the cell 10, and that would use the CS, the kernel mode code selector, to see, which in some cases, for example, to see GS, which is KPCR in the kernel mode in 64-bit Windows, or if it is in user mode, it will be the thread environment block. We can use, this cell to change the data selector to whatever we want and see from that selector. That's useful for FS and GS, for example. For example, if I do this LGS, sorry, I have to use numeric in this case. GS is 2B, so well, in that case it doesn't matter, but yeah. But then there is also a pseudo selector, which is this cell PHYS, PHYS. That makes it possible to see not virtual addresses but physical addresses, physical data. For example, I know my USB 3 XHCI controller in this virtual machine is in the address FE2000000. So we are seeing MMIO physical addresses here, but these are addresses that are not memory but the physical USB 3 controller in the machine, right? We can, by the way, change the data type by pressing numbers: 2 for word, 3 for dword, 4 for keyword, and 5 for symbolic info at keywords. But in this case, let's go to D words. We could, for example, press enter here and we can edit values, change, write, copy, paste, or we can dump or follow in ASM. This is useful for following, for example, the code pointers, return pointers in the stack or whatever, or we can follow in data, or in this case we can offset in data, which would pick the initial point of the window, add the offset and go there in data window. You can see there is a small number, the first D word is changing. By the way, this is not dead. I mean, this is live edition. If there is things that are changing either in memory, the Windows is frozen, so there won't be anything changed by itself in memory. But for example, since this is the MMIO for the USB 3 controller and that has a register that is the microframe counter, the one that you see there, we will see it change as it goes changing. That is something that not any code, but the hardware, the USB 3 controller itself has a ticker, like a clock, which is a 14-bit clock or something like that. And we can see, while it changes, we can see it changing automatically. In this case, this is read-only. I think it's not writable, but if it was writable, we could write it. Some of them are. This is not writable, I think. But the good thing is that we can see it change on real time, right? Okay, so let's, for example, continue execution with G. G command is continue or go. We can also press Ctrl D. Okay, so let's see, Windows was loading. Okay, so in this case, yeah, we have Windows here. Let's go to, for example, the browser. Open also some Windows. This is a virtual machine, so it's a bit slow, but well, Windows itself is a bit slow. It's still booting, but okay. So let's see if I can launch the browser. Yeah, you may restore it. I don't know. I had some video going on here. I think Bad Apple. Yeah, news, MSN, and this is a YouTube video for Bad Apple, which we still have adverts here, but yeah, fine. Okay. Come on. Nothing like refreshing. Okay. Yeah, it's a bit slow. I pressed it a little bit more.
Lo importante para ahorrar más es comprar mejor. Ariel Pots, todo en uno con extra poder quitamanchas. Para una limpieza que se ve
y hasta se huele.
Todo en uno, sin hacer más.
Ahora en Eroski consigue hasta un 50% de descuento en la segunda unidad de tus productos favoritos de Ariel.
If I press Ctrl D, it's the keyboard enter hotkey or combo key or whatever. We can continue execution. We can press and trace execution, which is quite fast. We are, by the way, we are in user mode here. We can see the selector column. The code selector is 0033, which is the user mode 64-bit selector for code, and then the offsets are, higher bits are 0, which is canonical addresses for user mode. Let's continue with G. So, by the way, still you can see there the microframe counter in the USB 3 controller is still as we are doing the debugging thing, it is still real-time changing, and we can see the changes real-time. Okay, so let's do G for continuing execution.
Solo hasta el 26 de junio. Corre, que vuelan.
Right?
Mantener fuera del alcance de los niños.
So now the actual video starts. Is the well-known bad apple. And again, we can press Ctrl D and we freeze the execution of the machine. By the way, you can see that, for example, if I move with Ctrl Alt and the cursor, I move the window a bit, you can see that the clock here, it says 19 whatever seconds AM, right? That won't advance. I mean, Windows is frozen now. Any processor is frozen. Only the debugger is running, right? Only this window, transparent bluish window, is responding to keyboard or mouse events. So let's go back to the debugger. We can trace execution here for a while. We are in kernel mode now. So code selector column to the left is 0010, which is the code selector, 64-bit code selector for ring 0 in Windows NT. And by the way, the offsets are high. I mean, the canonical addresses for kernel, which is first, I think 20 something bits are 1. As you can see there, selector, offset. We are still seeing the microframe counter of the USB-C controller, USB 3 controller, counting. I just use that as an example of the editor being able to do physical addressing or showing and all that. So yeah, let's trace some instructions with T. We could even use P as a step over, and eventually we would transition to user mode, probably. As soon as this is a user mode thread doing stuff in kernel mode, when it finishes doing that stuff, it will probably go back to user mode execution, and that is probably exiting via iRedQ or sysexit. Sysred. You would see as swap.js, maybe some flag changes, and we can see code nearby here. There is code that seems to be managing that, but we are not falling on that code, although we are near. Yeah, we can see some write MSRs. I think this 49 and some other are MSRs that were created with microcode updates, and they are for Spectre and Meltdown side channel attacks. I think 49 and some others, 48, I think. These are, if I remember correctly, these are MSRs that were created via microcode update for some processors to mitigate these Spectre and Meltdown issues. But anyway, that's not that important. We could, for example, here swap.js and iRedQ. That's an exit to user mode, or at least from an interrupt or whatever. We can do F4, which is here, but the code execution didn't arrive there. Press Ctrl D again. Here didn't arrive. It will let a temporary breakpoint, but it doesn't. It didn't trigger. So anyway, let's pass some instructions. So yeah, you can see, right? What I wanted to show you is we can freeze the computer completely. We can, for example, put a breakpoint BP on, well, let's unassemble NT open file, which is the typical API you would use in Windows kernel to open files. Let's put a breakpoint there. And as soon as I continue, it's probably a few seconds, it should fire the breakpoint and show the debugger again. That was instantaneous. As you can see, breakpoint 00 created, and I did G, which is continue execution, and it broke execution just soon after. Let's continue again. G, well, it's opening files a lot. I mean, I'm pressing G like continuing execution, but Windows is opening files all the fucking time. All the fucking time. I am continuing execution. Open file operations are being done and triggering the breakpoint. So the debugger freezes the execution of Windows and pops up. And we can see, for example, here we can dump in R8, which is the third parameter in this case. Let's see. Oh, we are in the data selector fish. We have to go back to data selector, for example, 10, for example, which is the code selector, but doesn't matter. It's enough to see. Now, let's toggle the window and put it in quad mode in the third part of the third parameter, which is the third parameter is an object attributes, which holds, among other things, the name, the string of the path name for the file, and the object attributes in the third field, it has a Unicode string. In this case, let's follow it. That menu, by the way, you can edit what you want. You can change it, copy, write, follow in assembly window, or follow in data window, or whatever, right? Or you can cancel it. But in this case, this is the pointer to the Unicode characters for the path name. Let's follow in data, and let's change back to byte mode. And as you can see there, I will change the cursor to the characters. You can see device / mileslot. That's some mileslot. Files in Windows can be actual files or can be other things that are devices or whatever, or symbolic links. In this case, device mileslot. Okay, that was just for you to see, you know, the NT open file breakpoint firing, and I am tracing execution now. We are now in NT create file, whatever, something into it. Well, that may be actual NT create file or other things. You know, the symbolic info is only for the sports right now, but yeah, in any case, I can pass or trace execution very fast here. And you can see, you know, functions being called and whatever. But let's continue execution and let the video continue. By the way, let's remove the breakpoint here. This is the NT open file. Let's remove the breakpoint. Now continue execution. And again, you can see that everything is working fine. Control D again, and we freeze it again. Well, I think that's enough. That was it. And yeah, thank you for watching. This is still, well, there is a lot of things going on here. The video hook. Also, I am still working on the USB support for USB 3 support for keyboard and mouse. Right now is PS2, but I'm doing things for that. And the video hook is UEFI hook, but also I have WDDM hook driver, like a parasitic driver, in order to be able to even actively create a frame buffer, even if Windows is not using it, or whatever application is not using it. We can force it, beneath the surface. We can get the frame buffer mapped in a CPU visible area and access. And yeah, that is, well, it's most done, but done for WDDM1 until 1.3. For 2 and upwards, I have to do some changes, but again, mostly done. USB 3 will probably be the next big thing to do. I started doing that. That's why I showed you that physical address with the micro counter and all that. The USB 3 controller, XHCI controller. And that's it, guys. So yeah, thank you for watching and see you soon. Bye.